Hello, everyone. In this video, we're continuing our work in example 3 in section 8.1. So we're going to look at part C. So that's the final part on this last example in this section. All right, so again, we're given a sequence and we're asked to determine if this sequence converges or diverges. All right, so there's a lot going on in this sequence, mainly because we have these radical symbols. So what I first want to do is just rewrite this sequence using exponents so that we're not too disturbed by those radicals. So keep in mind, if we have a square root of n, that's the same thing as n to the 1/2 power. All right, so what does that mean for us? Well, that means this numerator then looks like 2 to the n times n to the 1/2 power. So because we have n, same base, we just add exponents. And this n has an imaginary, not an imaginary, but a 1 exponent, we could say, if we wanted to actually write it out. So we add exponents, we get 1 plus 1/2, or 3/2. So the numerator just becomes 2n to the 3/2. Then what happens with the denominator? Well, that first term is similarly treated. So we get 3n to the 3/2 plus n to the 1/2 minus 2. So we can also write our sequence like this using exponents. All right, so now let's go ahead and set up that limit as n goes to infinity of 2 to the n, 3/2, all over 3n to the 3/2 plus n to the 1/2 minus 2. All right, so notice that here we have a similar behavior as what we saw in part B, where we have these terms in the numerator and denominator that are kind of throwing off what the behavior of this fraction or function actually is. So what we're going to do is use that same strategy as in the alternate strategy we saw, and we're going to multiply both numerator and denominator by 1 over n to the 3/2 in order to cancel that leading term. Okay, so what that's going to do too is give us a better idea of what happens in the long term with these as n goes to infinity by canceling out or kind of reducing that leading term, and then we can really compare what's going on. Okay, so then this becomes the limit as n goes to infinity of what? Well, we can go ahead and just write this out so we can really clearly see what's canceling. So we get in the numerator 2n to the 3/2 over n to the 3/2. That's our numerator. Then we get 3n to the 3/2 over n to the 3/2 plus n to the 1/2 over n to the 3/2 minus 2 over n to the 3/2. All right, lots of n's to the 3/2s. So let's look at what cancels here. Well, lots of things cancel. So these two n's to the 3/2s cancel, and similar on the denominator. What's left here? Well, we're going to subtract exponents, but notice it's a heavier exponent in the denominator. So what we can do is just cancel one of the halves, and then we'll leave an n by itself in the denominator. You see how that works? We have n to the 1/2. This n to the 3/2 is like n times n to the 1/2. So one of those n's to the 1/2 cancels, and we just get 1 over n. All right, and then here, no simplification we can do there because we don't have any n's in that numerator of that small function on the denominator. Okay, so let's then just simplify this out after we discussed how we'd simplify. So the numerator just becomes a nice 2. The denominator becomes 3 plus 1 over n minus 2 over n to the 3/2. So again, we canceled out that leading term by multiplying numerator and denominator by 1 over that leading term. Okay, so why was that helpful? Well, let's look at the behavior of each term in particular, or each term individually in this limit. So notice the top 2, that just stays at 2 no matter what n happens. 3, same story, just stays at 3. But 1 over n, that actually goes to 0 as n goes to infinity. Similarly, 2 over n, 3 to the 2 goes to 0. Because again, that denominator is blowing up, the numerator is staying fixed. Okay, cool. So what that means is that this limit then just becomes the limit as n goes to infinity of 2 over 3 plus 0 minus 0, which that's just the limit as n goes to infinity of 2 over 3, which is just 2 over 3. So this sequence converges. So we'd say, therefore, little 3 dots, therefore, the sequence converges to 2 over 3. All right, awesome job. Thanks for watching.